Hello students, hope everyone is fine and doing well. So in last class we discussed about the polynomial function, rational function and trigonometric functions, how to derive them, how to check their continuity and all. So like inverse of the trigonometric functions we discussed how to derive them, how to find dy by dx for such examples and so on, right? Now when you come to the next topic is exponential and logarithmic functions. So exponential functions means where the power of x keep on increases or the base value will be number and exponent will be variable. Let's take few examples like my first function f1 of x equals to x, or I'll take f1 of x as y, then y equals to x. Y equals to x is a straight line because it is a linear equation in two variables. So I think this line which passes through the origin, this represents me the y equals to x line if you see on the graph. Now similarly, if I go for y equals to x square, this is my second function. Y equals to x square, in class 10 we studied, it is a parabola. It will go like this, then it will go this way. It goes to a parabola. When I goes to y equals to x cube, this is my third function, f3. Sorry, here. f3 is the third function, x cube. Similarly, if I take x y to the power of 4, then the function will go something 4 times it touches the x-axis. No, this will go something this way, where all the values of 4 zeros will be equal. Okay, as you observe one thing, if y equals to x, that is x to the power is 1, the graph is away from the y-axis, little bit away from the y-axis. Exactly, you can see it between x and y-axis. When I take y equals to x square, it moved from here to here. When I take x cube, then it moved to here. When I take x power 4, it is moving towards the y-axis. That means if I take x power 5, it will move little bit more closer to the y-axis. If I take x power 100, it will go more further closer to the y-axis. It never be on the y-axis, but it moves closer and closer and closer to the y-axis. Okay. So here f1 of x is 1, f2 of x is x square, f3 of x is x cube, and f4 of x is x to the power of 4. Now what happens here is, as x moves on the positive x-axis from 0 to towards infinity, in the first case when y equals to x, the value of y increases very slowly. Okay, because if for example x is here, let me take this is 5, then y value is also 5. But when I take y equals to x square, if x is 5, then my y value is going to be 25 because 5 square is 25. When I take x is 5, then y equals to x cube function, y equals to 5 into 5 into 5, which will be 125. So as the power of x increases, y value is increasing faster and faster and faster, right? It goes too fast. Depending on, as the power of x increases, the value of y also increases quick. Okay. Now the question arises, is there any function exists which increases faster than this function, x to the power n? So let me type right here. What you have, let me insert the equation. First we have fn of x, because f1 of x I have taken as x, f2 of x we have taken as x square. If I take fn of x, so then this will be x to the power n. Okay, x to the power n. That means if n is 1, then I'll get, you may write here y equals to, okay, if n is 1, then I'll get f of x equals to 1 x. If f is 2, n is 2, then f2 of x is x square. If n is 3, f3 of x is x to the power of 3, and so on. It increases as n value increases, y value also increases faster. So my question is there any function exist which goes the value of y gives me more faster than the x to the power of n? So what do I consider is another function. For example, if I take y equals to 10 to the power x, y equals to 10 to the power of x. Okay, so these are the two functions I have. If you want, you can put here something f of x equals to 10 to the power of x. For example, let me check how these values are increasing. If I take what you can take x value as, if I take n value is 100, you'll get yeah. For example, if I put n value is 100 in this equation, so what it is going to be, control V. If I take n value as 100 here, then I'm going to get here x to the power 100. For example, if I take now in this function, and there are two functions, okay, if you want, let me highlight with the another color. This is one function and this is another function. Okay. Now let me take a different values of x and check. For example, if I take x value is some 10 to the power maybe x value is some 1000 I can write as 10 to the power 3, right? Now if I substitute x value in this equation, let me see what you are going to get. This you will get it as y equals to x value I have taken as 10 cube. So x value I can keep it as 10 cube, and in place of x also I will put it as 10 cube whole to the power 100. Okay, so in this case I can write it as a power m whole power n, which can be written as a power m into n. So this is going to be 10 to the power 300. Okay, so that is going to come 10 to the power of 300. So now next thing is going to happen is, let me talk about this function y equals to f of x. Now next step what happens here is, I take an x value is, this y is going to be, let me insert the equation only. So this y value is going to be y equals to f of 10 cube, right? And this is going to be f of 10 cube, which is equals to let me put the equation here. This is going to be 10 only, base is 10 only. Here power you have as x. So in place of x, I have to put 10 cube. So 10 cube value is going to be 100. Sorry, 10 cube is 1000. So you have 10 to the power 1000. So which one bigger you think? 10 to the power of 1000 is bigger, or 10 to the power of 300 is bigger? Obviously 10 to the power of 1000 is only bigger value. That means f y equals to x to the power n and y equals to 10 power x. In both the cases, your y equals to 10 power x function is going much faster than x to the power n function. Okay, so like this we can derive that there is a function which goes faster than the x power n, which is 10 power x function. Now we have some logarithmic formulas which need to be discussed. Before that, like if I take y equals to f of x, which is equals to b to the power x, this is some function. So b value is always a positive. The exponential function with positive base b, which is greater than 1, is a function. Here, for example, I have taken y equals to 10 power x. You can take, instead of 10, you can take 2 power x, 3 power x. The value must be greater than 1. You can take 1.5 to the power x. Anyways, this value is going to be bigger than the x power n function. Okay. Now it has some certain properties or formulas to be remembered. The domain of the exponential function is R. So in 10 power, the b power x value you can take positive or negative, no problem. Okay. So domain value is going to be always all the real number system. Any real value you can take as a x value. But your range is going to be a positive values only, positive real numbers. Okay, range of the exponential function is always positive real numbers. You may ask you, sir, if I take x value is negative, for example, you will take b power minus 2. B power minus 2 is 1 by b square. 1 by b square is a positive value. That means y value is going to be positive even if x is negative. That's why the domain of the exponential functions are all the real number system, and range is just set of all positive real numbers. Okay. Next, the point 0, 1 is always on the graph of the exponential function. Even in the graph also you have seen every graph is going to the point 0, 1 must be a point on the exponential. Sorry, not this one. These are all exponents. Okay. So next, what is an exponential function is ever increasing. That is, as we move from left to right, the graph is raises above. The exponential always, if you're going from negative number, left to right means from negative numbers to positive numbers, or from anywhere. If you start from 1, then you go towards the right only. The values will always keep on increases. Okay. Then for every large negative value of x, the exponential function is closer to 0. Here I have taken b to the power x. Let me show you here with an example what that property says. For example, if I take which function should I take? If I put y equals to f of x equals to if I take, for example, 3 to the power x. This is the function which I have considered. Okay, y equals to f of x equals to 3 to the power. For example, if I take x equals to minus 1, then what do you get? Y value. Let me put here y equals to 3 to the power, instead of x you will get minus 1. 3 to the power of minus 1 is nothing but 1 by 3. 1 by 3 is nothing but 0.33, and so on. It will continue. Now if I take x value is minus 2, then what happens? If x value is minus 2, this function is going to change as, if I take x value is minus 2, it is going to be 1 by 9. 1 by 9 means 0.11, something will come. Okay. So which one is bigger? 0.33 is bigger or 0.11 is bigger? Your 0.33 is bigger, right? So hence, even if I take 3 to the power minus 3, that is 1 by 27. 1 by 27 is 0.03 will come. 0.03. Even it is going smaller. So even the power of x is going, if I take smaller negative numbers, if I have to go minus 100, minus 1000, minus 1 lakh, then these values, y values will move towards 0. Okay, as the x value decreases, then the y value moves towards 0. That's the meaning of this point. Move left to right, for every large negative value of x, the exponent function is very closer to 0. Okay. In other words, that in the second quadrant, the graph approaches x-axis. So that's why, if you remember, Now let me see the graph. Y equals to x square graph is this way. As you move from bigger numbers to towards 0 here, the value will come towards this. Okay. So that's the meaning of that function, exponential function. Next, what we have is there are some there are some formulas to be understand here. Like if I have log x to the base b equals to y, log x and base is b equals to y, then b, if I send this side, it will go as b power y equals to x. If I want x value, then this b will go as the exponent base, so b power y, x equals to b power y, you can mention. So these are the graphs of the different base. If log x to the base 10, then the graph is this one. Then log x to the base e, the graph is this one. And log x base 2, the graph is this one. So every function graph is passing through the point 1, 0. Okay. So we can take negative values. The log function is not defined for negative values. So that means domain is only positive real numbers. The range of the logarithmic set of all the real numbers. You can see negative y values are also it is taking. Okay. So negative y values it is taking means range can be all the negative numbers. The point 1, 0 is always on the graph of the log function. The log function is never increasing, ever increasing. That is, as we move from left to right, the graph raises above. Even we studied for the exponential function also, the graph function increases when you move from left to right. So here we have the logarithmic function graph, y equals to log x to the base e, and this is the function y equals to e power x. Both are the one is opposite of another. That's why one looks like as the mirror image of other one. Okay, it looks like the images. So next two properties of the log functions are below. Yeah, first thing is log p to the base a. Okay, you can write it as log p to the base b, some other base, log a to the base b. Both the ways I can use. So these formulas you have to remember. Log p to the base a equals to log p to the base b, log a to the base b. Similarly, log p q to the base b. B can be anything. B value can be e, b value will be 2, b can be 10. B value can be any. Then I can write it as log p plus log q. If you have log p square, the formula is 2 log p. Similarly, log p to the power n is nothing but n into log p. If I have the division of two numbers with log x upon y equals to log x minus log y. Okay. Now there is one more formula, x equals to e to the power of log x to the base e. If I have e to the power log x to the base e, then the function is going to be x only. The question arises, is this true for all? Yes, this function is true, this formula. So if you want, let me write the formulas for one here, all the formulas. Here. What is the first formula we studied? So log functions we are studying, right? Summation exponent. There are no log functions. Okay, that's right here. Log. What is the first? Sorry. First formula we studied is log p to the base a. It's surprising why there are no log formulas. Just a second. Here we have. Here you have insert equation log b the power, for example, x you have. This can be written as first fraction will come. So log x with the base a, some base a upon, then again you can put this as log a to the log b to the base a. This we write it as study it as log x to the base a, and this one log b to the base a. A can be some any other number. We can split it this way. Second formula which we have is log xy to the base a. So this you can write it as log x to the base a. This is a and this is log x to the base a plus log x to the base b. Let me copy this one. Sorry, this is a and this is 5. The base will remain same and it will go as addition. Next you have is differentiation, division. If I take a here and this is some x upon y. So base is same, but we have here a division. So we can split it as log x to the base a. So this is going to be, these are the formulas which are going to use most. Rest other formulas we use very rarely. Here base a will remain same and this will go as y. Product is there, difference is there, and exponents will be there. Fourth formula, log, if I put a here and here it will be some exponential x to the power n. So you can bring that n front, n into log a x, log x to the base a. These are the most used formulas. The rest we use rarely. Okay. Now we have the main formula. Derivative of e power x is e power x, that we already know, and derivative of log x is 1 by x. These formulas we already knew. We studied in class 11 also. So we'll think of some examples, how to derive, what to derive, what to derivative. Till now we discussed just some explanation about the logarithmic and exponential function. Now first example, if I take f of x equals to e to the power minus x, e to the power of minus x. Okay. Now I have to find the derivative of this function. Derivative of this function is f derivative is going to be f dash of x. Am I right? This is going to be f dash of x equals to, I know e to the power x derivative is e power x only, but here I have minus x, so I have to go. I'm going to use chain rule. E to the power of minus x is e to the power of minus x into derivative of minus x. Derivative of minus x is going to be minus 1. Okay, so finally it is going to be minus e to the power minus 6. Okay, this is going to be this one. Sorry. Now if I take the second example, for example, sine of log x, sine of log x. If I say this is some y goes to sine of log x, now I have to find y dash. Then y dash is going to be, sorry, this is not 1, this should be y dash. So y dash is going to be first derivative of sine theta. If I take log x as theta, derivative of sine theta is cos theta, right? Derivative of sine theta is cos theta into derivative of theta. Derivative of log x is 1 upon x. So finally the answer is going to be cos log x upon x. Okay, so that is the answer. So chain rule comes anyway. We already discussed about the chain rule that follows every time. Next example, if I take, there are derivations are given. Just you can go through the derivations. Acha, cos inverse e power minus x. Let me try this one. So let me insert the equation. Cos inverse e to the power minus x. I have to put the bracket. So the typed form. This bracket will come. The exponential will e to the power minus x. This is the formula. Anyone remember the derivative of cos inverse x? We discussed in the last class. Any idea? Derivative of cos inverse x is minus 1 upon under root 1 minus x square. So this is going to be y dash. The derivative of y is y dash. Cos inverse x. I think the cos inverse x formula is minus 1 upon under root 1 minus x square. So minus 1 upon under root 1 minus x square will come. So in place of x, here you have e power minus x. It will come as e power minus x whole square. So let me put here e to the power minus x. This again exponential will come. E to the power minus x whole square, e to the power of minus x whole square. But the problem is not over here, because here in place of x I have e power minus x. So if I take e power minus x as theta, you will get cos inverse of theta. The derivative of cos inverse of theta is minus 1 upon under root 1 minus theta square. So I have written minus 1 upon under root 1 minus theta square into derivative of theta. Into derivative of theta means derivative of e power minus x. That we already got. Derivative of e power minus x is minus e power minus x. Okay, minus e power minus x. Now what happens finally is you can multiply this minus with this minus. So minus into minus, it is going to be minus into minus, it is going to be plus. So simply you have e to the power minus x. 1 into e to the power minus x is e to the power minus x, and this denominator term will remain as it is, no change in the denominator. So that's the answer of that function. So you have to apply a chain rule as well as exponential formula. Then what you have next example? Here you have e power x upon sin x. Here e to the power of sin inverse x. So let me take, for example, here u by v formula you can apply derivative of this function. Here let me solve this is e power sin inverse x. In such equation y equals to e to the power, here I'll get sin inverse x, right? This is my function e to the power of sin x. Now if I take sin inverse x as theta, then I'll get e power theta, right? E power theta, derivative of e power theta is e power theta into derivative of theta. So first let me write here derivative of y is going to be y dash. You can write dy by dx also. First e power theta derivative is going to be e power theta only into derivative of theta. Derivative of theta means derivative of sin inverse x. What will come derivative of sin inverse x? Any idea? Remember in the last class it is 1 upon under root 1 minus x square, under root 1 minus x square. Okay. Now you no need to do again derivative of 1 minus x square because I have to do derivative of sin inverse of x. So sin inverse x derivative is 1 upon under root 1. But in place of x, for example, here in place of x, if I have x square, then what will come is again derivative of x square will come. Derivative of x square is 2x. So that's how I have to extend my chain rules. Till I get x, my derivative will keep on extending. Next, what we have, next example or exercise question, e power x cube. So derivative of, let me take x cube as theta. So e power theta is e power theta into derivative of theta. So e power x cube into derivative of x cube is 3x square. So answer is going to be 3x square into e power x cube. So sin tan inverse e power minus x. So the chain will go twice. So let me take this function. It is sin tan inverse. Let me insert the equation. So y equals to sin. It will go as tan inverse e to the power. If you want, let me put again bracket. This is going to be e to the power of minus x. E to the power minus x. So this is the function which they are given. Now how do I differentiate this function? First let me take this entire thing as theta. So let me write here, let insert this equals to some z, instead of theta I'll put z. So what your function is going to become, y equals to sin z. Okay, if I do differentiation, you will get y to the power 1 will come. This is y dash. When I differentiate with respect to x, sin z derivative will be cos z into derivative of z will come dz by dx. Let me put here dz upon dx. Sin z derivative is cos z into derivative of z will come. So when derivative of z is coming, so let me type here. So y dash will remain as it is on the LHS. Y dash is equals to cos z into derivative of z means derivative of what you are taking z, tan inverse e power minus x. So if you want, let me write one step. Here it will come d by dx of tan inverse minus x. So tan inverse e power minus x. Derivative of this function will come, right? So next step is going to be this y dash, these things will remain as it is. Okay, no change in this function. Now what is the derivative of tan? Let me take e power minus x as theta now. Just e power minus x as theta. So tan inverse theta, what is the derivative of tan inverse theta is? Any idea the formula? Derivative of tan inverse theta is 1 upon 1 plus theta square. 1 upon 1 plus theta square. Theta square means e power minus x whole square, which is going to be e power minus 2x. E power minus x whole square. It is going to be e power minus 2x. Now again into derivative of e power minus x will come. Derivative of e power minus x is minus e to the power minus x. We already solved. So finally, if I replace this answer with z and everything, then I am going to get y dash of x. So this will give me y dash of x, then cos z is there. So what I do is z value I am going to replace whatever I assumed here. Z value is replaced into into this minus e power minus x also will come here only in the numerator. Okay. Now denominator is 1 plus e power minus 2x is there. So what I do here is let me rotate. I'm writing them in the properly. So denominator is going to be e to the power minus 2x. So this is the final answer of that question. So just chain rules you have to keep on apply. First, sine, whatever the inside sine of, this is sine of something. So whatever you have inside the bracket, that everything you replace with some variable z. Then it will become sine z. Derivative of sine z is cos z into derivative of z. So derivative of z means derivative of tan inverse x. What you can do here is, you may, if you want furthermore confusion, furthermore explanation, let this e power minus x again as e power minus x as some another variable. Maybe